Hey guys, it's Miss Johnson, and I'm here to bring you our notes for Unit 4 Notes 2. We're going to continue our talk on conditional probability. Today we're talking about conditional probability with tables. So our introduction that we did yesterday talked about the word given and how the word given tells us that we are finding the second probability after the first probability already occurred. So some event already happened, you're looking for the probability of the second event given the fact that the first event already happened. So you have to take that first event into consideration and you have to adjust your probability from there. Today we're talking about probability with tables where you're given some sort of condition that has to be true in order for the probability to be found. And that changes the probability if you were just looking at it out of the whole group. So we're going to look at a bunch of different tables today and talk about how our given probabilities change. So the first example, we're looking at a table of crimes and the age of the person arrested for a certain crime. So you can see the age groups across the top. You can see the different crimes that are along the side. You've got your totals for each column. So your totals are down here for each column. Totals are over here for each row. And total number of people in the table is 564. Okay, so it says, what is the probability that you select someone who was arrested for murder? Plain old, simple, one thing to look at. So if I'm looking at the number of people arrested for murder, I'm looking at the total of that whole row, which is 64. And I'm looking at the total of the whole table, which is 564. Basic probability here. This is like Unit 3, Lesson 1. No conditions are present, no multiple probabilities at the same time, none of that. So 64 divided by 564, I get 0.113 there. So 0.113 for my decimal. Let's look at the next one. It says, what is the probability that you select someone who was arrested for murder and is 16 to 22? So when you see that word and, that means you want both of those things to be true. So that means I'm looking at the arrested for murder row and the 16 to 22 column, and the number of people who fit both of those qualifications is 19. This is a both probability. This is one where we would take these two and multiply them together if we weren't looking at a table. Since we're looking at a table, we see the number of people who fit into both categories, and we take that out of the total. So 19 divided by 564. 19 divided by 564 is 0.034 when I use my rules of rounding there. And again, you might want to have your calculator out so that you can practice these with me, type these into your calculator, and make sure that you're rounding them the same way that I'm rounding them. Let's take a look at C. It says, what is the probability that you select someone who was arrested for murder or? Now we're looking at an or probability is 16 through 22. Arrested for murder or is 16 to 22. So arrested for murder, the total number of, so what this is an or probability. This is a probability where we would have added and then subtracted out the both, okay? So we need to add these two things, and then we need to subtract the duplicates. So when I do that, my total number of people arrested for murder is 64. The total number of people that are in the 16 to 22 category is 205. But the problem is 19 of those people got counted in both spots. 19 people were counted out of this 64, and 19 people are out of this 205. I can't count these 19 people twice. They're not two people, they're each only one person. So what I have to do here is take those two, 64 plus 205, and subtract the 19 that got counted twice. So that's what's happening for my total. I'm still out of the 564 here because I haven't had any conditions present yet. So my total hasn't been adjusted because there are no conditions yet. So 64 plus 205 minus 19, let's take care of that top. Plus 205 minus 19, I get 250 there. And I divide that by 564. 250 divided by the 564 is 0.443. So 0.443. And again, I knew to add and subtract the duplicates, so multiple successes, add your two successes together, subtract the things that fell in both because of this word or. I knew that I needed to do that because I had two successes here, because murder is a success or 16 to 22 is a success. Okay, now let's look at part D. Part D is, what is the probability that you select someone who was arrested for assault given that he is 16 to 22? Given this. So if the fact that he is 16 to 22 is a given condition, what that does is that adjusts your total. You are only looking in this column. Those are your only successes right there. Given the fact that he's 16 to 22 means that every person that you're looking at is in this 16 to 22 column. You don't care about the rest of these people over here. Your total changes. You're not looking at all 564 anymore. You're only looking at 205 of them because of this given condition. That's what makes it a conditional probability. This condition is given, I have to take that into consideration. So then I look for my successes. So what is the probability that you select someone who was arrested for assault? The people who were arrested for assault out of the 16 to 22 category, because remember, I'm only in this column now, is 49. So 49 out of 205 is my probability here. It's about a quarter, so let's see what we get here. 49 divided by 205, I get 0.239, 0.239 for my probability. So the given is what's going to tell you your new total. Given that he's 16 to 22 means 16 to 22 is my new total, and I'm only in that column. That's what happens when we're looking at this with tables. All right, same table. Now I'm going to look at a few more given questions. So part A, given the person selected is 23 to 30, what is the probability that they are arrested for robbery? Given this, given that the person is 23 to 30, that means that I'm only right here. Sorry, I can't draw a circle apparently today. So my total now is 147, and I'm looking at who was arrested for robbery. So I want this 102 out of 147, and that's my probability. Again, that given condition changes your total. You're not looking at the whole table anymore. You're only looking at that 23 to 30 because those are the things that's the thing that has to be true. So 102 divided by 147, I get 0.694 there for that probability. Let's look at B. Given the person selected is arrested for murder, given the person is arrested for murder. So this is your new total. What is the probability that they're 16 to 22? So I should have changed colors there, sorry. So given that the person is arrested for murder means that you're in this row. This is your given condition. You are not looking at anything else in the table except for that row. So your new total is 64. The probability that they're 16 to 22 is 19. So you've got 19 out of 64, which gives me 0.297 if I use my rules of rounding there. And again, bust out your calculators for me and type these things in so that you know you're rounding them the correct way. Okay, let's look at the last one. What is the probability that you select a person who is 31 to 38 given that they are arrested for assault? So given assault, that's your total. So now I'm in this second row down. That's my condition that must be present in order to find this probability. So I'm looking at the assault row. My total is 82. The 31 to 38 column, there are 4 of them. So 4 out of 82 is my probability there. And 4 out of 82 is 0.049. Okay. Let's take a look at another table. So now we're looking at a table where we've got grades 10, 11, and 12. And we're wondering if they prefer outside activities or inside activities. Okay. The thing about this table that's a little bit different is that you've got the probability of each piece already calculated inside. So you're not doing the fraction anymore. You're not doing like 10th grade out of the total. You're doing, you already see the decimal for each piece. So in the 10th grade row, you can tell that 47% of this table is made up of 10th graders. 23% of this table is made up of 11th graders. 30% of this table is made up of 12th graders. You can see that 64% of this table prefers outside activities, and 36% of this table prefers inside activities. So you've got your decimals already inside this table, which makes it a little bit different. If you think about percentages in general, the total number of percent that's ever available is 100%, which is why this table adds up to 1.0. Because if you add all of these people inside, all of these probabilities inside here, you should get up to 100% of the table, which would be 1.0. So it's just a little bit different way of looking at it. We're not looking at it in terms of counts. We don't know how many people are in this table. We don't know how many people represent this 0.42. We just know that it's 42% of the table that are 10th grade and prefer outside. Okay, hopefully that makes sense when you're looking at the probabilities. So let's just look at part A. It says, what is the probability that a 10th grader prefers outside activities? 10th grader preferring outside activities is 0.42. So the probability is given to us. I don't have to do any fractions. I don't have to do any dividing. This is just a standard basic probability reading it from the table. What is the probability that an 11th grader prefers inside? 11th grader preferring inside is 0.11. What is the probability that a 12th grader prefers outside? 12th grader preferring outside is 0.10. Okay, so those are all just basic probabilities that I'm reading from the table. Now let's look at how we would apply the given here. So in the next example for this table, it says given the person selected is a 10th grader, given the person is a 10th grader, what is the probability they prefer inside? So given the person is a 10th grader means that I'm in this row. Now, here's where life gets a little bit tricky. You've been told in the past that you can't have decimals within fractions. Guess what? That's kind of a lie. You can have decimals within fractions. What we do here is we divide the successes out of the total just like normal, even though they're in decimal form. So given the person is a 10th grader is my total. 0.47 is my total. What is the probability that they prefer inside activities is this 0.05. So basically you're asking, out of this 47% of people, what's the percentage that they prefer inside activities? Well, it's 5% out of the 47%. To do 5% out of the 47%, I have to divide. So again, it's weird to put decimals inside fractions. However, it is something that we can't do. So 0.05 divided by 0.47, and I get 0.106. There. Did I round right? Yes. All right, so 0.106. So about 10, almost 11% of the sophomores prefer inside activities. What that means is then 89% of the sophomores prefer inside, or I'm sorry, I said that backwards. 11% of the sophomores prefer inside activities. That means 89% of the sophomores prefer outside activities. And if you took 0.42 out of 0.47, that's almost the total. Divide that, I bet you'd get about 0.89. Okay, so what is the probability that a person prefers outside given that they are a 12th grader? Notice that your given condition was at the beginning of the sentence in part A, but your given condition is at the end of the sentence in part B. It can be written either way. That's the good thing about the English language is you can change how you write up these sentences. You have to watch this word. Whatever comes after this word given is your total. So given that they are a 12th grader means that we are in this row. Given that they are a 12th grader is that row. Then we're looking at what's the probability that the person prefers outside. Outside is the 0.1. So I have 0.10 out of 0.30, which is a third, 0.333. You can get rid of the zeros, you can get rid of the decimal points because they're in the same place, and you've got 1 out of 3. So 0.333 there is your probability that given a 12th grader, a person prefers outside activities. All right, one more here. What is the probability you select a 10th grader? Oh, basic easy. What's the probability that you select a 10th grader? No other conditions there. No ands, no ors, no other givens, nothing else. You're just looking at the 0.47. Probability that you select a 10th grader is 0.47. That's it. One more example of these, same table, still looking at probabilities given inside. So given the person selected prefers inside, that means that we are in this column. Given the person prefers inside, what is the probability that they are an 11th grader? That's 0.11. So here's my total. I've got 0.11 divided by 0.36. 0.11 divided by 0.36 is about a third. 0.306 there. If I use my rules of rounding. Okay, so let's take a look at B. What is the probability that a person prefers inside given that they are an 11th grader? Ooh. So check this out. It looks like it's the same thing as part A, but your given condition is different. In part A, your given condition was that they prefer inside. In part B, your given condition was that they were an 11th grader. So I'm looking at the same successes, but I'm looking at a different total. Given that somebody is an 11th grader means I'm in this row, and my total is 0.23. I'm back at this 0.11, which is what I also used in part A, but my given condition is different. So I need to be in the green row instead of the red column. So I have 0.11 out of 0.23. So that's where you really have to be careful about what is the given condition. The given condition is the one that comes after the word given. So up here it was given this. Down here it's given this. 0.11 out of 0.23, you're at about a half there. 0.478 is my probability. What is the probability that you select someone who prefers outside? No given, no and, no or, no two probabilities you have to put together, no two successes, you got to subtract duplicates, no changing the total. It's just a basic, what's the probability you select someone who prefers outside? Preferring outside, 0.64. And again, these were already given to you in probabilities, so there's no dividing necessary. If you were to divide here, you'd take 0.64 divided by 1. Well, 0.64 divided by 1 is still 0.64. You don't have to go through that hassle, that exercise of doing that division, because it's just going to give you the same answer. All right, that's it for our lesson for today. Hopefully that gives you a little bit of a picture of the using conditional probability with tables. If you have any questions, feel free to contact me, and thanks for listening. We will talk next time.